Welcome to myprojectbazaar.com. We are going to see the product for fully integrated 10 GHz active circulator and quasi-circulator using Readme networks in standard CMOS. Next we are going to see the abstract for our product. Circulators with 3 or more ports and non-reciprocal function blocks used in microwave and millimeter systems that separate incident and reflected waves. To reach the next port, the incident signal at one port circulates in only one direction, namely clockwise or counterclockwise, and non-adjacent ports are isolated from each other. Conventional circulators are usually fabricated with passive non-reciprocal ferrite materials, but using ferrite materials make them expensive as they are not compatible with monolithic integration. The most important specifications of active circulator and quasi-circulator are their inherent advantages such as size, weight, and cost over conventional ferrite devices. In our product, we have designed circulators and quasi-circulators with Readme networks. To eliminate the use of ferrites, the use of non-reciprocal characteristics of transistors for an active circulator was first reported. The 3-port circulator with 3 MHz operation frequency used 3 transistors in a ring-type configuration. The modified 3-port circuit designed with FETC in which their sources were connected together, and the 6-port circuit in hybrid by cascading amplifiers and couplers in a ring-type configuration based on the topology. The small signal circulations of the 3-port CMOS circulator using the QC using 1 BTN. A BTN is an asymmetrical 3-port network which features a notch frequency response. Next we are going to see the flow diagram for our product. It consists of circulators and quasi-circulators. The circulators and quasi-circulators is based on the Readme networks. Circulator has 3 ports and the quasi-circulators also has 3 ports. The design of the circulators will be analyzed by scattering parameters. The 3-port unit cell for an n-port circulator and its scattering parameters. Each port is assumed to be perfectly matched. BTN uses signal cancellation technique and a band reject characteristic to reject S31 respectively. Both QC and BTN utilize the inherent non-reciprocity of transistors to suppress, then small values of S31 and the S13 are also assumed. Therefore, P1 and P3 are mutually isolated ports. The signals from port 1 to port K can be expressed by combining the clockwise and counterclockwise signal flows. It is practical to design a 3-port circulator using the 3 QCs based on the type 2 PTN topology. It is predictable that the circulator using type 2 PTNs will result in high power consumption and increase the circuit complexity due to the external amplifiers. Through the type 1 BTN, the function of a QC, a 3-port circulator, could be also achieved using the BTNs. The internal port 2 and port 3 S32 is increased to minus 0.3 dB and is decreased to minus 49 dB. The significant noise response of S31 is attributed to the BTN, and the internal inductor and load is mainly affected by the feedback resistor. Finally, we are going to see the output for our product. We have designed the circulators in the LT space. This design is the CMOS quasi-circulator using the type 2 Readme network topology. The Readme network uses signal cancellation technique and a band reject characteristic to reject S31. Both quasi-circulator and bridge-T network utilize the inherent non-reciprocity of transistors to suppress S30. The small values of S31 and S13 are also assumed, and therefore P1 and P3 are mutually isolated both. The capacitor C3, C4 and the feedback resistor are the basic elements of the BTN. The cascode topology consists of the common source CS stage and common gate stage for improving the isolation of S12, which can also be recorded as the external amplifier. The cascode amplifier M3 and M4 is the internal amplifier for enhancing the gain of S32 and the isolation of S23. The inductor L3 not only works as a source degenerator inductor of the internal amplifier to decrease noise performance, but also features the function of the internal inductor LG. It is predictable that the circulator using type 2 BTNs will result in high power consumption and increase the circuit complexity due to the external amplifiers. The type 1 BTN does not provide the function of a quasi-circulator. A 3-port circulator could be also achieved using the bridge-T networks. The output is based on the output from the RF resistors. The significant notch response of S31 is attributed to the bridge-T network and the internal inductor, and low S13 is mainly affected by the feedback resistor. Next we are going to see the design for the circulators using 3 BTNs. The capacitor C0, Ci and the feedback resistor RF are the basic elements of the BTN. The amplifier in the type 1 BTNs provide high gain and high isolation to achieve a circulator. Therefore, a CS amplifier and a CJ amplifier constitute the internal amplifier, which is also recognized as a cascode amplifier topology. RG is a high resistive resistor processing a DC path. The L0 and C0 are used to form the interstage matching network. LI and CA are utilized in the input or output matching networks. Thank you.